So find the fifth roots of 4. So the fifth roots of 4, so Z1, the first root, is equal to the fifth root of 4. And we'll use our calculator. So we've got 4 to the power of, you can say 1 divided by 5, or you could put 0.2 if that's easy for you. And there we get the value of 1.32. So let's try that. So we've got Z1, our first root, Z1 is equal to 1.32. And are we right? Yep, so far so good. We're going to use this number for every root, so let's store it in memory. So we go variable, we'll stick it in A, so we'll say OK, store it. Okay, so that's now in memory location A. Now let's have a look at where the other roots are. So this root here is Z1, which is the fifth root of 4, so that's the 1.32 that we've just calculated. Now there are 5 roots here, so we're going to divide 2 pi by 5, which is going to mean that this angle here is 2 pi over 5, this angle is 4 pi over 5, this angle is 6 pi over 5, and this angle is 8 pi over 5. But also notice that this number and this number are complex conjugates of each other. This number and this number are also complex conjugates of each other. So to find Z2, we're going to say that Z2 is equal to, I'm going to call this R, cos of 2 pi divided by 5 plus I sine 2 pi divided by 5. Okay, we'll use the calculator for that. So we'll do the first bit, the cos 2 pi, which is the x value. So we're going to clear that and say that we want to recall A, times the cosine of 2 times pi divide 5, and the answer to that is 0.41. So let's put that in Babbage. So we've got Z underscore 2 is equal to, that is 0.41. That's the real part. Now we'll do the imaginary part. So we'll go back along our equation and we'll change the sign, we'll change the cosine to sine xe, and that's 1.25. So we've got plus 1.25 I. Are we right? Yes, we are. But that also means that we know another root as well. So we can say that Z3 is equal to 4.1 minus 1.25. Because if we look here, this is 0.41 plus 1.25i, and this value here is 0.41 minus 1.25i. So are we right? Yes, we are. Okay, so now we need to calculate these two. So as before, we'll clear the calculator and we'll call our value back for r. So OK, recall. And we're going to multiply that by the cosine of 4 times pi divided by 5. Close brackets, and that's equal to minus 1.07. So the next value, let's just drag this down a little bit. So Z4 is equal to minus 1.07. That's the real part. And now for the imaginary part, we'll change the cosine to sine. And that's going to be sine. And that gives us 0.78. So that's going to be plus 0.78i. And are we right? Yes, we are. So that means we now know the final root, which will be, so Z5 is equal to minus 1.07 minus 1.78i. And are we right? Yes, we are. And that is how you calculate the fifth root of 4. Question 4b, find the 4 roots of 2. So let's move that out of the way. I've got a diagram of that, so let's paste that in. So the 4 roots of 2. So we've got 2 real roots here, and we've got 2 imaginary roots here and here. There are no complex roots, just 2 real and 2 imaginary. So first of all, let's calculate the real root, which is the 4th root of 2. So let's clear that calculation, and we want to do 2 to the power, and for a 4th that's a quarter, so that's 0.25, and that is equal to 1.19. So this value here is 1.19. This value here is obviously going to be minus 1.19. This value here is going to be 1.19i, and this value here is going to be minus 1.19i, which means that we can now just put all our answers into Babbage. What we're going to say is Z1 is equal to 1.19. Are we right? Yep, we are. Z2, and Babbage doesn't mind which you call Z1, Z2 and so on. This is going to equal 1.19i. Are we right? Yep. So Z3 is going to equal minus 1.19, and Z4 is going to equal minus 1.19i. Are we right? Yes, we are. And that's how you get the 4 roots of 2.